Whoop whoop.
Hello, this is Yegor Guy from Leafcloud,
Hey there.
and today we are going to nerd out. What we are going to do is we're setting up a GPU compute machine, and we're just gonna run some like Hugging Face stuff on it or whatever. So I logged into our Leafcloud environment. This is the only CO2 negative cloud in the world. And this is our demo project. We're just going to launch an instance. Let's see, we have some documentation about how we can set up an easy to use GPU machine.
Awesome.
Yeah, with NVIDIA drivers pre-installed, Pytorch, TensorFlow, Keras, Jupyter Notebook, the whole shebang. So we're going to use this Ubuntu Pytorch TensorFlow. TensorFlow? Looks like we have a typo there.
Oh yeah.
What?
Typo detected.
Typo detected. The instance name is going to be Hyped Up Jupyter Notebook Tutorial. There we go. We're going to go to the source. So yeah, that is.
Don't forget the typo.
The typo. There we go. So we're going to add this one. We're just going to up the volume size, let's say, to 40 gigs. The flavor.
Sure hit that minimum.
Yeah, we don't want to sit on the minimum. So we're just gonna go for a single GPU instance. This stuff that you see here is just because those are huge instances that will go over the quotum of the demo project. Networks, we're going to give it an external IP address, so it's going to be publicly available.
Awesome.
And this is my, public-private key pair thing. Default. Let's see if we have SSH open. Yeah. So there we go. Going to launch the instance.
Up and running.
Get it up and running. So this is going to be our public IP address. Block device mapping means that it's creating the volume, it's encrypting the entire thing. That's our default setup. That takes a couple of minutes. Let's see. So in the meantime, we're going to start a terminal. I'm going to... no, so we're just going to have to wait a little bit. We're going to go into it like that. My... private key is already added to my SSH, the key manager. In the meantime, let's look for some, interesting examples that we're going to try to run. Actually, I also had another machine where it was already playing around with some, machine learning models.
And how did that go?
It went well. I intended to make a tutorial out of that, but I ended up just playing with machine learning models, constantly having a feeling like, oh, this is not done, it's not done, and I ended up not recording a video. That was kind of ridiculous. So what are we going to do? Are we going to generate some pictures? Are we going to generate some text? Are we going to summarize stuff?
I think it would be fun for the folks at home if we generate some pictures.
So, okay, let's see. So Hugging Face is a website full of open source and free to use machine learning models. And Stable Diffusion is a popular generative model. So let's see if we can get like a nice Stable Diffusion Jupyter Notebook. So diffusers, let's see, Stable Diffusion, Hugging Face, Jupyter Notebook. original Stable Diffusion Notebook. Maybe this is it. Yeah, that's from Hugging Face. How old is this? January 17, not that old. So this is a notebook. Yeah, let's try this one.
Yeah, we'll
let's
try
see
this
if
one.
we can get this to work. We're probably gonna get a bunch of errors. That's how it always goes, and then we have to, like, I don't know, install some libraries, and we'll get there. And we have some time. So let's see if the instance is already running.
We see that over here.
No, it's still mapping.
Oh, it's still mapping.
Yeah, it's a 40. It has to.
It's a big boy.
Yeah, it has to encrypt 40 gigabytes. It just takes some minutes. So let's see what we're hoping to make. If the internet loads. So Stable Diffusion is a text image latent diffusion model. Blah blah blah. Basically, what this does, let's go through it. So it checks the NVIDIA drivers. Then it's going to install some requirements.
Oh.
Then it's going to import Torch. It's going to import the diffusions from the Stable Diffusion pipeline, one of the requirements that it installed. Then it's going to load the model from so it's going to load a pipeline that loads a model.
Awesome.
Based on Stable Diffusion 1.4. So we just saw that 1.5 is the latest. This is not the latest, but it's fine. Then it's going to tell the pipeline to use the CUDA drivers, which are pre-installed on this image. Then it's going to define a prompt, a photograph of an astronaut riding a horse. Then it's going to generate the image. Then it's going to save the image to a PNG. And then it's going to display the image. Right? Then he's going to do generate a couple more.
Are these all based off the same prompt?
Yeah, those are based off the same prompt with different seeds.
Yeah.
And different inference steps. So you can basically change some hyperparameters also if you want to have some different results. Then it's going to show how to generate multiple and show them. And then it's going to it just goes into how to make like a whole grid of them, change the resolution, and I think, and here it just explains more about what it is. And I'm not sure. We won't get to the end of this. Let's just try to get here first.
It's a good first step.
Let's see if the still encrypting. Well, I could have done an unencrypted volume, but I don't know. I never feel safe. I feel so naked when it's unencrypted. So this is starting on a Leaf site. EG1 means E means eco. G is GPU, and 1 is the availability zone. We only have 1, so.
So this is hosted on what we call leaf sites, where the energy is reused.
Exactly. So running this machine will actually reduce the amount of gas being burned for making warm water. So by recording this tutorial and running this machine learning algorithm, we're actually going to reduce CO2. Yeah,
awesome.
Which is kind of the whole point of Leafcloud. So let's actually open our Jupyter Notebook tutorial again. So what are we doing? We did these steps: press launch image. We selected this image, we set it to 40 gigabytes, we use a GPU flavor, added an external network, we SSH, select the security group that exposes the 8888 port. We didn't do that yet.
We haven't done that.
We didn't do that. So let's just, it started up. That's cool. we're gonna edit the security groups. We're just gonna add. Whoa, I have so many things. I don't know which one is what. We're gonna just go to network, security groups. My colleague says we should just pause and check the recording. So we're gonna do that. All right, the recording setup works. We checked it. Here's the recording, so that's great. What are we doing? We're going to check the security groups. We're just gonna create a new security group. We're gonna call it Jupyter Notebook. Create security group. Then we're gonna add a rule. Ingress port 8888 from anywhere. Fine. Add. Then we're going to add that security group to our instance. Edit security groups. Jupyter Notebook. Save. Okay, so now 888 is exposed. We're going to SSH into the machine. This is because I'm just reusing an IP address, so I need to So my machine recognized that the fingerprint of this machine is different from the previous machine that used to have this IP address, which is a security feature, but I know this is my machine. So the previous one was just a different demo machine. So what we're going to do is we're going to say systemcdl, sudo systemcdl, status Jupyter service. This will actually give us link with token that allows us to log in to Jupyter Notebook. Otherwise, we wouldn't be allowed in. Deceptive site ahead. Bum, bum, bum. Not deceptive. This is ours. The thing is, it doesn't have HTTPS, so it's not actually deceptive. It's just not secured. It's HTTP. If you wanna add HTTPS, that's fine. It's possible. Just need to add certbot. It's just an extra step that we're not gonna do right now. This is not something private. So what are we doing again?
We're starting a Jupyter Notebook.
We are starting a Jupyter Notebook. We chose one. So which one did we choose again? We actually downloaded one. This one.
Yeah.
This is Diffusion. What we want. We just want this one file. I'm just gonna download this onto the machine. So we're gonna go into. Wait, let's see where this Jupyter Notebook is actually running. So this is running in my home directory. So we're just gonna say wget this file. So this file is now in the directory. We can open it here. Yeah, deceptive side ahead. I'm not decepting myself.
I don't feel deceived.
We are not deceived. Does not appear to be JSON. Okay, there we go. So I didn't download the raw file. So I downloaded the web page displaying the file instead of the file itself. So we're gonna have to like copy the link over here and do download again. What? Oh, sorry. wget. So wget just downloads files basically. Wait. Now I'm just gonna remove both. Then do it again. There we go. Home page. So deceptive site ahead. Okay.
Here we go.
That's the Jupyter Notebook. Now we're just gonna see where it is gonna crash or if it's already working. So it's just gonna show us that this is the state of the GPU. Looks good. Now we're going to install the dependencies. Just installing the diffusers. That's the like Hugging Face stuff from Stable. Well, diffusers actually is not a Stable Diffusion thing. Stable Diffusion is just a brand name. So some transformers. That's also a Hugging Face thing. SciPy is a. Or I'm not sure if that's a Hugging Face thing. It's like a machine learning data transformation thing, and SciPy is scientific programming library for Python that has some machine learning. It has some data transformation. It has some it's just a popular, easy to use but not so fast tool. FDFY, I have no idea. Accelerate, I have no idea what it is. Wiktionary, I bet that's not it, but I do want to know what it means on Reddit. Fixed that for you. No, it's this one. This is found in the row. Can fixing mix-ups by detecting patterns of characters. Okay, it's some natural text fixer, probably to improve the prompt. Accelerate SciPy. Let's see what it is. So that's kind of some GPU thing. Accelerate was created for Pytorch users who like to write the training loop of Pytorch models, but are reluctant to write and maintain boilerplate code needed to use multi-GPUs. What? We could do a multi-GPU setup.
Now, isn't that interesting?
That is. We can go up to 8 GPUs, but we're not actually gonna do that. It's interesting. We can try it out next time,
maybe for the next tutorial.
See how crazy we can go. Did it already install the requirements? We have crazy fast internet on these machines, by the way. Yes, it did install all the requirements successfully. I'm almost surprised. Nice.
Well done.
So looks like this is no, this is not the notebook.
Oh.
That was the pre-made notebook. It did actually do it, so good for us. So we're just going to download the model now and create the pipeline. This is going to take some time. The models are normally quite big. I don't know, usually a couple of gigabytes for more advanced like machine learning models. The thing is that
there we see it go.
Yeah, a couple of gigabytes. Well, lots of gigabytes actually. See how fast this is going? All of these things individually are going like with 30 megabytes per second. It's fast. I like our internet. Look at that.
And so when this is completed, we'll have the models?
Yeah, these are the models downloading right now.
And then our next step will be?
Our next step's going to be tell the pipeline that we're using a CUDA accelerated GPU driver, and CUDA is the mathematics framework written by NVIDIA that can run very fast and parallel on NVIDIA GPUs.
Oh.
So that's what most machine learning algorithms use. That's it. That's the model downloaded. What is it warning us about? Config attributes, scaling factor, something were passed to autoencoder KL, but are not expected and will be ignored. Please verify your config.json configuration file. So it looks like something in the configuration was not picked up, a scaling factor of 0.18215, which may mean that the prompt, if I have to guess what this is, because otherwise we have to look at the source code and it'll take some time. I can, but we'll just do that if it doesn't work.
That sounds good.
This is probably going to influence how much of the prompt and how much of the realism it's going to choose.
Yeah. incorporate in the eventual image.
Yeah, I've
Right.
seen that before being called scaling factor. But let's just see what it does. If we're not happy, we'll just go into the code and see if we can do something about it. So right now we're just saying pipe to CUDA. I think now we actually have like a running pipe or a configured, an instantiated pipeline. So here we go, a photograph of an astronaut riding a horse. Let's just
Let's go with the same one.
The same one?
Well, let's go with the same prompt. See what we get.
Okay, so boring.
After that, we can give him a hat.
I'm already bored. I thought you were gonna hype.
Did you want to do something bigger? Something better?
Something so much better. Look at that. We have a horse with an astronaut on it. Look at the neck on this. Oh my god.
You know what? A good horse's neck is something of pure beauty, and that is not it.
That is not it. Let's just do a couple of, wow, I like this. Oh my god.
Hey.
This was so easy. Hey, this is the same one because we predefined the seed. So that actually works. Then let's just do a grid, and then in the grid we're just gonna play around a little bit, yeah?
That sounds fun.
That's amazing. This is amazing. Did you see how easy that was?
That went really easily.
We have spent 30 minutes, and we have quite an advanced machine learning algorithm running. We started up the instance. We had to wait for 7 minutes for the entire disk to be encrypted. We configured a new security group with a security group rule. We checked the token for opening the Jupyter Notebook. We went through the Jupyter Notebook image tutorial on docs.leaf.cloud. And we chose a new algorithm. I've literally never used this before. Now we are generating a whole bunch of images. I am actually kind of curious what would happen if we throw a huge instance. So let's just generate a couple of these, and then let's see what happens when we do a 4 GPU setup. We'll do. Yeah. Oh, we need a prompt. Okay, so let's just copy this guy. We're just gonna make a little copy of that.
Yeah, let's bring that over.
Sorry, this is the copy button. Why didn't that? I guess you have to first paste this. So we copy pasted it.
Mm-hmm.
New prompt.
New prompt.
Okay.
Yeah.
What do you want?
So, I'm a massive Kevin Bacon fan.
Kevin Bacon. Oh, what's up with my caps? Kevin Bacon. Is that written like that?
I think so.
Okay.
And, well, from my improv days, I always liked things with water sports. So, let's add a jet ski to the mix.
Okay. Kevin Bacon eating escargots on a jet ski.
Perfect.
There we go. Jet ski, is that one word?
It is now.
It is now. Let's go. It's quite fast, actually, isn't it? It generated these, how many images? 1, 2, 3, 4, 5, 6, 7. I bet I can see this in the code. 8, 9, 10, 11, 12. Now let's see how we can see that in code. So 3 by 4. So
there you go.
Was very unneeded to count, but whatever.
3 by 4, commonly known as 12.
Commonly known as 12. This is true.
No.
Not a square. It's a rectangle. It's a rectangle.
Yes, it is.
I am pretty sure. Or is it triangle?
Isn't everything a circle if you zoom out far enough?
Everything's a triangle. No? Subliminal.
There we have him.
Oh my god! Where he is trying.
Now that is Kevin Bacon eating
escargots on a jet ski. He's actually doing it there.
That's what we wanted. This has made my day.
Look at this one. Who is this friend? Look at this one. He's so cool. This guy is so cool. Okay. Okay, let's do another one. I love this. Wait. Let's do a high resolution one.
Ah, yeah, there we go. Let's see. Let's take the baby for a spin and see what we can do.
Let's just keep like doing multiple. Let's do a 2x2. Well, a 3x2, great. It'll be a little faster. And wait, how did they do that? Prompt. I'm just kind of improvising. I don't actually know how this works. So how did they ingrid all images? Prompt is num calls prompt. Here. So prompt pipe prompt. So it's doing this. So I guess that's higher resolution. 3x4. Let's just do a 3x2.
There we go.
Let's do a
no squares.
2x2.
Yeah. Make it 2x3.
1x3.
There we go.
Okay. Run it. No, still Kevin Bacon.
No.
We need a new prompt. Wait, I'm gonna just ask our anonymous colleague for a prompt. Can you come up with a prompt for us? Adam Sandler having lunch with a penguin. Okay. Adam Sandler having lunch with a penguin.
I think for those of you competent with ChatGPT, you've already got the beginnings of a good movie outline here.
Are we gonna feed this to ChatGPT? Maybe we can. Nah. Let's just keep playing with this for a while and call it quits. I'm wondering what's gonna happen.
So we're going for high resolution here and seeing if that
yeah,
command actually...
higher resolution.
Oh, well, it is higher.
Oh my god!
That is definitely higher. There's an odd-looking penguin, though.
It's Adam Sandler looking like a penguin. You see that?
Ah.
It is him. And there's
there's the
Sandler
penguin.
and the penguin.
Oh, there we go.
Oh, he's so happy. Why is it every time two Adam Sandlers? It's his family or something, or what?
Is it just multiple Adam Sandler? Well, there he's dressed as a penguin.
They are dressed as a penguin. This is an abomination.
It's fascinating, though. And the resolution is higher.
Oh, why does he have 3 hands, of which one is a bit suspiciously positioned? All right, let's just see if it can generate. I don't know.
Milk cartons in space.
Workings of a neural network based diffuser. I don't know, something like that.
Sounds good.
Let's see what it makes of that.
Very meta.
Very meta. Yeah, we're breaking the 4th wall here, guys. The 5th wall. Looking right into the cameras.
Leafcloud famously does not operate with walls.
No. Wow. It's actually generating some wannabe text. Look at this. Oh my god, this is the source code of the Matrix. You see that?
This really does look like the mainframe, doesn't it?
It does look like the mainframe. Oh, this is a nice explanatory pictogram. I got much wiser right now. You know what? I think that's it.
I think we proved that it works.
Yeah.
Well done.
And good luck playing around with this stuff. I mean, this is of course not just for fun. This actually works for serious algorithms. This is just something kind of to prove the concept and show you how quickly you can get it up and running and help you when you want to do something yourself.
If you do end up doing anything yourself with us, let us know in the comments. And thank you, Igor, for taking us through this little tutorial.
Thank you for being here and having a good mood.
Well, it happens once a year.
Great. Okay. Bye-bye.
See ya.